MySQL Security Basics Part 3 of 3. In this nugget, we round out our three-part mini-series on general MySQL security. In this time, we focus on the network subsystem. In particular, how to secure that very vulnerable aspect of MySQL Server. In the second part of this nugget, we look at one of the many storage engines included in MySQL Server, the federated storage engine. We cover the federated storage engine in great detail from soup to nuts in the DBA1 CBT Nugget product. However, it's not a prerequisite for you to own that to learn this objective. Here we're going to review what federated storage engine does, and we'll look at the security implications of this storage engine and how we can improve its security in MySQL Server. Let's get rocking. General network security tips. First of all, just an obvious point, MySQL is a client-server network application, and because of this, MySQL will listen on a particular service port. Now, any TCP/IP application, if I can spell once again, is going to be bound to one or more IP addresses and listen on at least one TCP or UDP service port. Now, we don't have the time, and it's not really within our scope to give a full consideration of TCP/IP theory. The take-home message for your DBA2 exam objectives are to know, first of all, that the MySQL network surface by default listens on Transmission Control Protocol TCP port 3306, and that TCP provides reliable connection-oriented services, like many network services do. Now, as a systems administrator, it's up to you on whether you want to keep MySQL on that default service port or if you want to change it out to a different port. There's pros and cons to each approach. I mean, one no-brainer idea is, since a bad guy knows that MySQL listens on 3306 by default, then he or she is going to set their targets on that service port right out of the box. On the other hand, because your filtering software and your security implementation may already be aware of this, you may have strictures in place such that this port is already filtered and protected, and you have access control lists and rules, and so there's that principle, if it ain't broke, don't fix it. Moreover, you may have line of business applications and application code that has hard-coded calls to TCP 3306, and if you were to get jiggy with it and just decide to change the service port on the back end, you'll suddenly get complaints from your users because your application's breaking. Therefore, it's not a trivial thing to change the service port of MySQL unless you do it at the very beginning of your implementation. Alright, I think I've over-explained a little bit, but I've nonetheless brought up some important points. Okay, next point on this whiteboard, something I've talked about a little bit earlier that bears repeating: secure all your default accounts. We saw in the previous nugget when I ran the demo of doing a installer-based installation in Windows that you have the opportunity to enable remote root user access. We're going to see that in the upcoming demo in this nugget. Also, the ability to enable anonymous connections. I found that Unix-Linux distributions, especially when you compile from source, it's easier to develop a secure by default installation than it is with Windows. We want to be careful on two fronts. One, not to enable any accounts we don't need in MySQL, and also to make sure that any accounts that are there have strong passwords. And out of the box, there's not much of anything really by way of password auditing. You're on your own as far as either developing your own tools for this or looking at third-party solutions. In the upcoming demo, I'm going to show you how we can query the mysql.user table to look both for local and remote accounts as well as anonymous accounts, and then we can easily dump those extraneous users that we don't need. Finally, on this whiteboard, this is an important idea here. At least with Linux Unix distributions, I've had very bad luck getting this to work in Windows. We have a built-in Perl script called MySQL Secure Installation. This is a really nifty, user-friendly script that makes short work out of doing some of the things that we've been talking about that are really the baseline actions that any MySQL DBA should do immediately post-install to tighten security of your MySQL system. In other words, setting a strong root password, disabling remote root access, making sure that you don't have any test database there in your default data directory, and no anonymous accounts. I think the reason why we don't have the MySQL secure installation script in Windows is in Windows we have a very GUI environment, we don't have Perl support out of the box, and we have that graphical configuration wizard as we saw in the previous nugget that has not all, but at least 3 of the 4 of these options built into that GUI functionality. Continuing on our golden road of network security tips for MySQL Server, let's drill into the server network interface. Again, looking specifically for the moment at TCP/IP. Now, you'll see, and we'll discuss this in just a minute, that MySQL does offer support for some additional networking protocols, but you and I both know that now in the 21st century, and really it's been this way for the last decade anyway, at least, the TCP/IP protocol stack is the de facto networking protocol here. So obviously that's the focus of the exam objectives and the focus of what you're doing in your real life work. I'd bet $20 to a stale box of chocolate chip cookies. Alright, so what I'm showing you here is a screen grab from a sample my.cnf or my.ini configuration file. And in the MySQLD portion of said file, we have some directives. Now, this is silly. You can't have all 3 of these active at once. It's mutually exclusive. But first of all, let me explain the difference between skip networking and bind address. Now, one way to give your server a nice kick in the pants as far as disabling remote access across the board is to pop in skip networking in the MySQLD section, restart MySQL, and you're off and running. Skip networking is effectively your kill switch for TCP/IP. Now, if you come from a Microsoft SQL Server background, at least with SQL Server 2005 and above, you'll remember the surface area configuration tool, and that's been supplanted with SQL Server 2008. Actually, it's been removed, not supplanted. But the idea was that Microsoft realized that enabling remote connections by default in a relational database system is not a very secure or wise thing to do. Therefore, if you've got skip networking in there by default, this prevents anybody meaning anybody with a capital A, period, from making a remote connection to your server unless and until you as an administrator come in and either remove this line or comment it out, you see? So that's what this is. So if you're finding, hey, wait, why can't anybody, including myself as root user, make a remote connection to my MySQL server? Make sure to open your option file and see if you have skip networking in there. It's there for a very good reason, for a security reason. Now, alternatively, skip networking is considered a little bit old-fashioned because it's just, some DBAs might consider it to be like killing an ant with a sledgehammer. A more, shall we say, compatible, a more elegant solution to skip networking is to use this bind address directive. And what we'll find in the most recent distributions of MySQL Server is bind address equals 127.0.0.1. Now, I'm sure you know this IP address is the local host address, the loopback IP address. In other words, if you have bind address equals 127.zip.zip.1, this enables TCP/IP stack and enables remote connections with air quotes, but the connection, the IP address that MySQLD is listening to is the local host only. And so therefore, functionally, no users are going to be able to establish a remote connection to the box, you see? So given these 2 options, I would formally recommend you go with bind address equals localhost just to maintain that compatibility and to keep your TCP/IP pipes clear, as it were. And then when you're ready to bring up the server in production, what you do is simply substitute the local host IP address for the live IP address that your server's listening on. Simple as that. Now, in addition to TCP/IP, which is going to be your general purpose workman-like protocol for remote connections and even local connections for that matter, local connections in particular may proceed faster, dollars to donuts, by using either Unix sockets for Nix platforms or named pipes for Windows. Now, if you want to disable this stuff, you can. I frankly wouldn't suggest it because for IPC, or what are called inter-process communications, these are really the way to go. It's much faster to use these because these protocols are much closer to the core operating system files, the Unix sockets and the Windows named pipes. And again, these protocols are within the server only. They cannot be used to go over the network, and they're used simply for local access. They're very fast and very efficient for that reason. So you'll find oftentimes for local connections to the server, you're using sockets on Linux, named pipes for Windows. That's just what MySQL will choose for you. Federated table security. As promised, I wanted to give you a little bit of background on the storage engine if you didn't have any before we dive into the security-related aspects. First of all, Federated is a storage engine. As you probably know at this point in our skill set, MySQL supports pluggable storage engines. Storage engines define the specific storage format and features for your tables. Federated storage engines provide a cost-effective and resource-effective alternative to database replication. Let me give you this picture and describe this picture to you, and it'll make a little bit more sense. Imagine you want to make a table available on more than one server to serve maybe two different user populations. We could be talking about a development environment and a production environment. We could be talking about two production environments in two geographic areas, 2 floors in a building, or maybe 2 areas separated by a wide area connection, whatever. And maybe you didn't have the money or the skill resources, etc., to develop a full replication architecture. Of course, MySQL does support replication. An easier way to go about this is to use federated storage engine on one of your database instances. Now, here's the way it works. Let's say on MySQL Server B you have a table called T1, and this table could be using any other storage engine. We could be using, for instance, MyISOM, or in this case, InnoDB. Now, this is the table that contains your real rows. In other words, your data rows are actually physically stored on disk here on Server B. Now, over here on Server A, this is an actual separate server, could be in the same rack as Server B, could be in a different room, different building, different state for that matter. And what we're doing over here on Server A is, number one, we do have to build a table with the absolutely identical structure as the one on Table B. So really, your best practice is to do, say, a show create table and to develop a snapshot of the exact SQL that went into the development of T1 here and duplicate that table shell over on SQL Server A and create that empty table, but you'll do some additional SQL, and I'm showing you that down here. Because instead of InnoDB, you're going to be using the federated storage engine. And one awesome thing, I think, about MySQL and the fact that you do have this flexibility in storage engines is that different storage engines can be called into play to solve different kinds of challenges as a database administrator. For instance, InnoDB is awesome for its transaction support. Federated is awesome for this particular reason, for remote access to table data. So what we do here is we'd specify engine equals federated, and then, here's the money, we would specify a connection string using this URL syntax where we use the MySQL protocol prefix, and then you see what we're doing here. This actually looks like any uniform resource identifier, or URI, oftentimes referred to as a URL. I'm not going to get into that whole match of the differentiation between a URI or a URL. We can talk about that some other time. Email me if you want to. We'll just consider these synonymous terms for now and call it even. How's that? But at any rate, we have the username and the password of the remote MySQL user on the target system. So in other words, we're sending over root and a password that's valid not on Server A, but on Server B. @ is our separator. And then we have our remote server name, in this case sql1.corp.com. That's obviously server B. And then we're pathing out to the target database and then the target table. So city really should be T1 in this case, but I think you get the idea. It's pretty straightforward if you've worked with URLs or URIs, in particular if you've ever worked with FTPs and using the browser, or what I often call when I create them, a single-click link for an FTP URL. Now, the security issue with this, which I'll get to in just a moment, is that the actual raw SQL, the connection string here is in plain text. So we have a user account credential here that's completely unprotected. But before we get into the specifics of that, what does this actually do? At the outset, once you create your table here, you wind up still with an empty shell table, but you've got this really cool federated link, kind of an umbilical cord, that connects T1 on SQL Server A to T1 in MySQL Server. I said SQL Server A, didn't I? Of course I mean MySQL Server A to T1 in MySQL Server B. Therefore, the replication idea is now our users can query against T1 on MySQL A, and all those queries are going to work and they're going to return rows. However, the actual data is being pulled over the wire. In other words, we're not storing any data locally on MySQL A. All of the real row data remains on row B. That's the whole principle of federated table security. Now, from a performance standpoint, I hope it makes sense that you're going to need to bump up the jams in terms of your network pipe, because depending upon how often you're hitting up that table, this federated link is going to get some action. Number two, I hope that your CPU and memory and disk subsystems are up to snuff on MySQL B, because this guy is going to be hit not only with users coming in to it directly, but also from remote requests coming over the federated link. Therefore, there's security concerns that we're going to talk about specifically in this nugget, and also performance tuning concerns that we'll be dealing with in the second half of this entire series. Now then, in the next whiteboard, let's talk more about the security Achilles heel of this plain text connection string in our federated storage engine create table statement. Federated table security continued. Now that we know the main Achilles heel of federated tables, namely the fact that in the definition of the federated table, we have the exposed connection string, we need to know a little bit more about the details of this in terms of what are the limits of the exposure, who can see that connection string, and then how do we fix the problem. First, who exactly can see the connection string besides our root or administrative users? Well, really at base, any user, any MySQL user who has the ability to run show create table against the federated table or show table status can see the code, can see the create table statement, and therefore can see the connection string. Therefore, the fix is just a general best practice really for any good DBA, and that is to restrict user access to the federated table in general. This is good practice because, as we've previously discussed, we want to keep users away from the base tables as much as possible anyway. And remember, at the beginning of this course, I gave you a couple good ideas for that. One is that we can construct views and funnel our users through views instead of base tables. Another even better thing we can do is use stored procedures and then just grant the users the call ability or the execute permission, and then have them call the stored procedure. The stored procedure then will run queries against the table. Now, at the file system level, this is more controllable and calls to mind operating system and file system security. If the user has access to the format file, the FRM file, this again would allow the user to expose the connection string. The fix there is to restrict access using file system permissions and disallow ordinary users access to file system objects. In our demonstration, we're again going to be using both platforms. We're going to be working with both Linux and Windows, and we'll be reviewing some of the techniques of securing network access. We'll also be testing federated table security. Essentially, we'll just be setting up a simple table, and I'll show you how to do federated storage engine work. It's a good skill to know how to do from front to back because you're bound to see quite a bit of coverage on federated tables on all of your MySQL exams. And away we go. We're beginning this demonstration on the Windows Server 2008 Enterprise Edition box named WinNugget 1. We're going to accomplish two goals in this demo. One, configuring networking support for MySQL, and two, managing the federated storage engine. Now I've got a couple things going on here. Let me open up my.ini, which is the configuration or option file for MySQL Server, just to show you that that didn't come out of thin air. I can get that from my installation directory, which is on this Windows box in a custom location, C MySQL5 my.ini. And let me just walk you through this file. If I scroll down under the MySQL D section, the server section of the file, you'll see a directive called port. This is where we can change the default TCP port for the server if we want to. I'm not going to, of course. I'll add a new line called bind address. In my.ini file, there's no skip networking directive, and there's no bind address. What do you say about that? And I am going to activate TCP/IP, and I'm going to instruct MySQL Server on WinNugget 1 to listen to 10.0.0.1. I'm going to save my changes and minimize the file because we're going to need it again. Let's just check our networking. In Windows Server 2008, I can open the Start menu, right-click the Network option, come down to Properties. This opens the Network and Sharing Center in Windows Server 2008. I'll then manage my network connections under Tasks. It always takes so long to get to your dadgum connection properties. I'll right-click Local Area Connection, come down to Properties, double-click my TCP/IP v4, and I'll validate my IP settings. Well, wouldn't you know it, I'm actually statically assigned the IPv4 address 10.zip.zip.2. Well, I'm glad I checked. So we better come back to my.ini, and I'm going to change that bind address to 10.0.0.2. Another thing I'm going to do, and what you'll want to do if you're using DNS, of course you'll need to make sure you're using DHCP or static addresses. On a server, you're probably going to be statically assigned, just like I am on mine. But you'll want to make sure that your DNS configuration is valid and working. Now, on my simple configuration, 2 machines, if I want to communicate with LinNugget 1 rather, not LinNugget 01, using host names rather than IP addresses, I'll want to make sure that I have LinNugget 1's IP address in my hosts file, which in Windows, you probably know this, is under C, Windows, System32, Drivers, etc. So I'll pop open the hosts file in Notepad. Believe I already corrected this. Sure enough, I've got an entry 10.0.0.2 for WinNugget 1, 10.0.0.1 for LinNugget 1. Good. So far so good. Can open up an administrative command prompt, which I already have open. And the way you do this, if you're a Linux person and you're not sure, in Windows Server 2008, you can open up an elevated or an administrative command prompt by right-clicking the icon and choosing Run as Administrator from the shortcut menu. I'll just go ahead and first I'll ping the IP address. That's up, so I therefore should have no problem pinging the host name, and I don't, so that's good. So we're good to go with that. Great. Now the final thing I want to do in terms of Windows configuration before we get into the security aspects of anonymous accounts and remote access and that kind of stuff is to make sure I have federated storage engine installed on this box, because a little bit later in this demo, when I do federated storage engine support, I'm actually going to use WinNugget here as our federated box, and we're going to host the real table with the real rows on LinNugget, our Linux machine. Now, I didn't mention this in the whiteboard section of the course, but MySQL, although a default installation will give you the federated storage engine, it's disabled by default. Now, how can I prove that? I can prove that by logging into MySQL, which I'll do now, and I can run show engines. And if I run show engines and scroll down, we have under entry 5 here, engine federated support no. So we see, let's see, most of these are enabled by default. Obviously my ISOM is, CSV is, the merge storage engine is, the black hole is, InnoDB on this server, and all MySQL servers, unless you compile from source, is the default storage engine. All these are actually activated except federated. Therefore, the question is, how do we activate it? Well, you can activate the federated storage engine from the command line, but then you'd have to do it again every time you start the server. So your best bet is to return to our trusty configuration file, come back to our MySQLD portion of the file, and just put in one word, federated. Simple as that. We can click Save. I'll close the file this time. Let me quit out with a \Q. When you make a change like this to the server section of the option file, we're going to have to bounce the MySQL service. So we're going to do a net stop MySQL and then a net start MySQL to make that change go into effect. Therefore, we can test this by logging back into the server and running show engines again. And we now see federated is supported. So we can build tables using that federated storage engine. Alright, so while we're on WinNugget, let's stay in MySQL now and take a look at some security implications network-wise pertaining to users. So what I'm going to do here is use MySQL to make things easier. And what we're going to run is a select statement. We'll show select user, host, and password from the user table. And what we're going to see here is something a little different from a couple nuggets ago when we queried this table last. We see user root host localhost. Now that's fine. That's our built-in root MySQL user account. Now you notice you also see user blank host localhost. And we also see user blank host %. Now you remember the % operator is a wildcard which stands for anything. You also see user root host %. Now what those entries are number one, this third entry means it's allowing root access from any host in the world or remote root connections. And the second and fourth entries are anonymous connections either locally or from anywhere in the world. And you notice even more scary, the password fields are blank for the second and fourth entries. Now those were actually created for me because in preparing for this nugget I installed MySQL for Windows, and when I ran the configuration wizard, you'll remember one of the steps is we can instruct MySQL to allow remote root access and or enable anonymous connections. And really all it's doing there is running a create user statement with, if you do an anonymous user, you're doing a blank username with a blank password. Actually, a blank user, and if you're doing a blank host, it's like this, an empty string, an identified by, and then a blank password. That's kind of what it looks like in code. This is what it actually looks like from the table point of view. Just want to show you this because if you're ever in a consulting role, you're going to want to run this query to take a look at your customer's user table and spot these kind of issues right off the bat. Therefore, the first thing we're going to need to do to tighten up security on this user table is to run a couple selectively placed deletes. First of which we're going to say delete from user where password equals empty set. Let's run the select again, and now all we have are two statements, one that's allowing root from localhost, the other one that's allowing root from anywhere. Now, it's up to you on whether or not you want to keep that second option there. But at least we've now deleted our anonymous accounts. Okie dokie. We're over here on LinNugget 1 now. Without going through all the specifics, because you know the drill, I've already opened up the my.cnf option file and I've set the bind address to the logical IP of this machine, 10.0.0.1. I've logged into MySQL, and let me show you what I've done to set things up for our federated table here. I'm going to select user and password from user. Actually, let me adjust that query, host from user. I've created a user named Fed from the host WinNugget1, and I've granted sufficient privilege to Fed on a database that I created called Test1 that's going to serve as our container for our federated table. Now remember, this is going to be the specific user that's going to be pipelined from our WinBox over here to LinNugget1. That's a crucial step. You don't want to just use the root account here. We want to use least privilege. So I've created a dedicated account for the federated connection, and again, that's called Fed, and it's crucial that we specify the host from which it's coming, otherwise the account is going to fail, isn't it? Now, let me run a show databases, and as I told you, we have test1. It's just an empty database now. We'll use it. Haven't created the table yet. I'm going to do that right now. I'm going to call it T. I'm not feeling very creative. We're going to have two columns. Column 1 an integer, column 2 is varchar 10. Remember, this has to be identically mirrored on the WinBox. Let's do a show create table, test1. Well, you get the name of the object correct. Engine is my ISOM, which is the default, so we're just making this as plain vanilla as possible. And we're going to insert 3 rows in here really quickly just to give it some data to start with. Good deal. Looks like we're ready to go here. We have our base table on LinNugget 1. We have our bridge account. So let's bop on over to our Windows machine and finish this configuration. Alright, so on WinNugget, you see I've logged in as root. I've already created the test1 database. I'm using that test1 database, and I'm now creating a table. Now, by the way, I didn't have to mirror the entire database. I can create the federated table anywhere in the instance on the remote server, but I've decided to just mirror the database shell just for consistency. The main body of the table definition is identical to that on LinNugget 1. I'm closing out the table column declarations. The only difference here is the engine statement. I'm specifying the federated engine, and then my connection string, I'm providing the clear text ID for the user and the password at, and then the remote server name, LinNugget1, and then the remote database name, test1, and then the remote table name, T, and then we'll finish it. Query OK, 0 rows effective. So if we run a show create table T, just as I promised you, the connection string is available in plain text. So that proves that. Now the proof is in the pudding. Can we now, if we run show tables, run queries against T even though we know the real data in T exists remotely? And sure enough, we can. Therefore, we're able to run queries against this data, and depending upon our level of privilege, even run updates, inserts, and deletes against this data across a network connection. MySQL Security Basics Part 3 of 3 Review. In this nugget, we looked at 2 main aspects of MySQL security from the network point of view. In general, we looked at securing the network environment in terms of network protocols, network interfaces, and network accounts. I feel pretty strongly that over the previous 3 nuggets, we've built the content upon itself in a pretty linear fashion, and you have a pretty darn good idea of the basic mechanics of keeping MySQL safe and secure. In the second half of this nugget, we examined an important, functional, and yet sensitive storage engine in MySQL Server, and that is the federated storage engine. We looked at how it works, how to implement it, as well as how to keep it as secure as possible given its inherent weaknesses. I hope that this has been informative for you, and I'd like to thank you for viewing.